Hello dear children, in this video series, we shall learn some questions regarding how you can solve equations and inequalities using logarithm, right? Okay, equations and inequalities using logarithm. You'll be solving equations and inequalities with the help of log. You can use the laws of a logarithm to transform equations in order to make their solutions accessible, means easy. We are going to use logarithm so that we can transform the equations into simple form. Let's have a look at example 15. Solve the equation 4 raised to power x equals to 16 by taking log on both the sides. Actually, you can solve this question orally, right? How can we get 16, children? It is 4 raised to power 2, and over here this side it is 4 raised to power x equals to 16, right? So that means x equals to 2, right? This is easy. Orally also you can solve, but they have asked us to solve it by taking log. Suppose I have 4 raised to power x equals to 16. How can I solve this? Take log on both the sides, children. Take log on both the sides. So log of 4 raised to power x equals to log of 16. Now how can you write this 16? You can write this 16 as, now first of all take this log in the front side, x log of 4 equals to log of 4 square. 2 comes in front, so you will be left with x log of 4 equals to 2 log of 4. You can reduce this log 4, therefore I am left with x equals to 2. Is it clear, children? Easy? Very easy. Okay. How did we solve this? How did we solve this, children? Okay. Now see, we shall move towards the next part. The next part is this question. Okay, fine, let us try to solve this. Okay, fine, the next part. Okay, solve the equation. Now here I am having an equation 5 raised to power x equals to 3 raised to power 2x plus 1. 2x plus 1. Take log on both the sides. So I'll be having, taking log on both the sides, I'll be having log of 5 raised to power x equals to log of 3 raised to power 2x plus 1. Now this x comes in front and this 2x plus 1 also comes in front. So you'll be having x log of 5 equals to this 2x plus 1 also comes in front. 2x plus 1, the power becomes the coefficient, log of 3. Now children, what you are going to do? You are going to expand the bracket. X log of 5 equals to 2x into log of 3, 2x into log of 3 plus 1 into log of 3. Okay. Now take x on the same side. Take it on the left hand side. So you'll be having x log of 5 minus 2x log of 3 equals to log of 3. Now you can take x common from left hand side. So you will be left with x log 5 minus 2 log 3 equals to log of 3. Take it at the denominator. So you will be having x equals to log 3 upon log 5 minus 2 log 3. Use your calculator and you will get the answer minus 1.869. Okay children, let us move ahead. One important feature of the power and logarithmic function is that they are strictly monotonic. That is, they are always increasing if the base is greater than 1. We have explained this earlier also, right children? And they are always decreasing if the base is less than 1. So, if logarithms are equal, it follows that expressions are equal. If logs are equal, then the expressions would be also equal. Example, 17 and 21 express both sides as a single logarithm and use this feature to remove the logarithm to enable the equation to be solved. We'll be doing these questions, this kind of question, what I mean by this statement in the further examples. Solve log of 2 plus x to the base 10. 2 plus log of x to the base 10. Everywhere we are having log 10 and log 10 except this. Now children, tell me, how can I write 2 as log something to the base 10? Tell me, what should be over here? What should be over here? Why I am purposely writing it to the log 10 to the base 10? So that I can match it with all other logs. Now see children, this goes this side. 10 raised to power 2 is how much? It's 100, right? So, log of 100 to the base 10 equals to 2. Now, this whole equation can be written as log of 2 plus x to the base 10 equals to, this 2 can be written as this expression, log of 100 to the base 10 plus log of x to the base 10. Now this is addition and we are having log on both the sides. So we will directly multiply 100 with x. Okay children, we can do that. Are you getting this children? Okay, now what shall we do? See children, over here we have log, keep it as it is. Log of 2 plus x to the base 10 equals to log a plus log b, can be written as log a into b. Log a into b to the base 10. Now children, can we remove log from both the sides? Yes, we can. So 2 plus x equals to 100x. Take it on the other side. You will have 2 equals to 99x. So x will be equal to 2 upon 99. Is it clear children? Easy. What was the twist over here? I had to write 2 in the form of log something to the base 10. And what was that something? How did we derive this value? 10 square is 100. Okay. This was the twist over here. I hope this is clear children. Let us move ahead. Another important consequence of strictly monotonic property is that inequalities can be solved by considering the case of equality. If inequalities are given, we will take them as equality so that we can solve the question. Then selecting the values above or below that critical value as appropriate. We will be doing this. See, here is an example. 5 raised to power x less than equals to 13.3. Now what shall we do? We shall take log on both the sides. I am also taking log this side. So this comes in front. So I'll be having x log 5 equals to, I can take this as equality first of all to solve it, right? Converting this inequality into equality. Log of 13.3. Now what can be done children? Take this at the denominator. So you will be having x equals to log of 13.3 divided by log of 5. Use your calculator and you will get x equals to 1.608. So as you are having this expression 5 raised to power x must be less than equals to 13.3. So your x must be less than equals to 1.608. Understood, children? Okay, clear? Let us have a look on the other question. Now this is strictly less than. Okay, children? Take log on both the sides. Log of 0.4 raised to power x equals to, you will be having log of 0.0001. Taking log on the both sides, they come this side, x comes on the left side, so you will be having x log of 0.4 equals to, now this is log 0.001. Take it on the other side, you will be having x equals to log of 0.00, I forgot one 0 over here, 01 divided by log of 0.4. Okay, use your calculator and you'll be getting the answer. You'll be getting your answer x equals to 10.1. Now see, children. Now you are having 0.4 raised to power x must be strictly less than 0.001, right? So your x, you got x as 10.1. Okay. Your x must be greater than, your x must be greater than 10.1. Now here you might be getting confused, right? That why we didn't had x less than 10.1, right, children? That also will be solving it over here. See, children, over here you had log of 0.0001. This can be written as log of 1 upon I put an extra 0 over here, 1 upon 1000, right? Is it correct? Have I committed any mistake? Initially we were correct, children. It must be okay like this. Fine. Yes. So you'll be having over here x log of 0.4, right? Now this can be written as x log of 0.4, that is 4 upon 10, equals to log of 1 minus log of 10,000. Okay. Now see, children, here the explanation is also given to us. Instead of going through all this, let me explain you. Power of 5 gives a monotonically increasing function since 5 is greater than 1. That was for initial, first one. It will be increasing. But for decimal, children, for decimal, that is if it is less than 1, greater the power, if there is something less than 1, suppose I have 0.5 less than, greater power, the value will decrease, right? Okay, value will decrease. So we are having 0.4 raised to power x must be less than 0.0001, right? So this value must be greater so that the function decreases. This x must be greater, right, children? This x must be greater so that the function decreases. Okay, so that's why we are writing x greater than 10.1. Or for understanding this, we can also consider inequality itself. X log of 0.4 must be less than log of 0.0001, right, children? When you will solve this, take this as equality. When you will solve this, you will get x equals to 10.1, right, children? If it is 10.1, 0.4 raised to power 10.1, your value will be approximately equal to equal to, yes, 0.0001. But as the value is greater than this, if I take x greater than 10.1, orally also you can solve this, children. If x is greater than 10.1, your value will be less than this, right? And they have strictly said that it must be less than. So your x would be something greater than. Why greater than? Because this is less than 1. If it had been greater than 1, then your x would have been less than the answer. Okay, children? Let's move ahead. How many terms of the geometric series 2 into 1.1, 2 into 1.1 square, 2 into 1.1 cube must be taken so that the sum exceeds 1000, right? The sum must exceed 1000. Okay. So you know, if you solve the sum of n terms of GP to be 1000, it will almost certainly give a non-integer value. The solution will be next integer above that value, right? They have said that it must be sum exceed, right? The sum must exceed 1000. So how we are going to solve, children? You know the formula for Sn. What is the formula for Sn, children? Sn equals to A as my the difference, or you can say the common ratio is greater than 1, I will write r raised to power n minus 1 upon, see here it is given to you all, r minus 1. Sn equals to a r raised to power n minus 1 upon r minus 1 is the sum of n terms of GP with first term as a and common ratio as r. What is the common ratio over here? It is 1.1, right? When you divide this by this, you will be having 1.1. When you divide this by this expression, you will be having 1.1. Okay, so we will write this as, we will take first of all equality, right? Okay, so solve this. You will get 50 equals to 1.1 raised to power n minus 1 implies 51 equals to 1.1 raised to power n. Now take log on both the sides. Take log on both the sides for this expression. So you'll have n log of 1.1 equals to 51, right? So n equals to 51 by log of 1.1 and your answer would be 41.25, right? So n must be greater than 41.25, right, children? I told you, right, that over here it is greater than 1. So n will be always obviously greater than 41.25. Now what is the number greater than 41.25? Which natural number is greater than 41.25? It is 42, right? It is 42. So 42 terms would be needed so that the sum is greater than 1000. Okay, children, clear? Solve the equation log of 2 minus x to the base a minus 2 log of x to the base a equals to log 3 to the base a. Here all the base are a, right? Okay, children. So what we are going to do, children, see log a minus log b. Log a minus log b. This can be considered as log of 2 minus x minus, can I take it back on x so that I can write log, let us keep a over here and a over here, log of x square equals to log of 3 to the base a. Log a minus log b equals to log of a, log a minus log b can be written as log a by b, right? Log of a by b. Let me write that log of 2 minus x upon x square, right? I can write this like this, equals to log of 3 to the base a. Can we remove log on both the sides? Yes, we can do that. So I'll be left with 2 minus x 2 minus x upon x square equals to 3. Now solve this. So 3x square equals to 2 minus x. Take it on the left side. 3x square plus x minus 2 equal to 0. Factorize using splitting the middle term. You will get x equals to, let me solve this also. 3x square, 3 to the 6 and 3 minus 2 is plus 3x plus minus 2x minus 2 equal to 0. Splitting the middle term, children. So you will be getting over here 3x x plus 1 minus 2 x plus 1 equal to 0. So I'll be left with x plus 1 and 3x minus 2 equal to 0. When you take this as 0, x plus 1 as 0, you'll get x equals to minus 2. When you get 3x minus 2 as 0, when you take 3x minus 2 as 0, you'll get x equals to 2 upon 3, right? So here are our answers. This was 1. This was 1, children. So I'll get minus 1 and 2 upon 3. Clear? Let us move ahead. A culture contains 3 lakh bacteria at 9 am on Monday and increases at a rate of 20% every hour. At what time will there be 6 lakh bacteria? Right, children? The number of bacteria, T hours. In how many hours? In T hours after 9 pm on day is given by, see children, this also forms a geometric series or exponential function. Initially the amount was 3 lakhs, right? And it increases at the rate of 20%. Okay, children, 20% means how much would there be after 1 hour? It will be 20% more, right? 20% more. Okay. So it will become 1.2. Now, how did we get this 1.2, children? Suppose the increase is written as 20% and it increases at a rate of 20% every hour. 20% every hour. See, children. Okay. Suppose I have 1 bacteria initially. Now, after 1 hour, it increases by 20% of 1, right? 20% of 1 means 20 upon 100 of 1. So it becomes how much? So solving this, you will get 100 plus 20 upon 100. That is 120 upon 100. That is 1.t in first hour. In second hour again 1.2 raised to power 2. In third hour, initially for the first hour, right? Initially it was 3 lakh. After 1 hour it will be 3 lakh into 1.2 raised to power 1 after 1 hour. In the second hour 1.2 raised to power again 1, right? In the third hour 1.2 raised to power again 1 hour, right? First hour, this is second hour, this is third hour. So in T hours it will be 3 lakh into 1.2 raised to power T. And we want how many bacteria? We want 6 lakh bacteria, right, children? Okay, so this reduces to 2. You will get 1.2 raised to power T equals to 2. Take log on both the sides. Okay, so T log of 1.2 equals to 2. Take it on the other side. T equals to 2 by log of 1.2. So your answer would be, using calculator, your answer would be 3.8017 hours, right? 3.8017 hours. So initially it was 9 am. 9 am plus 3 hours again. 3.8 hours, right? Let us round it off to 3.8 hours. 9 a.m. plus 3.8017 hours. When you add this timing, when you increase this timing by 3 hours, and what is this 8 now? What is this 8.8 hours? You'll convert that into minutes and your answer would be 12:48 in the afternoon, that is PM. Okay children, now they are saying 2 million bacteria. They are saying 2 million bacteria. Now what do you mean by 2 million bacteria? 20 lakh. Ones, tens, 100, 1000, 10,000, lakh, 10 lakh, right? 20 lakhs bacteria, and that the expression for that will be again 3 lakh into 1.2 raised to power t. Use the same process to solve. You will get t as 10.405, right? It was 9 a.m. 9 a.m. plus 10. It will be something 19 p.m. 19 p.m. means 12 plus 7. It will cross 7 p.m. and now 0.405 hours. Convert this into minutes and add up that timing, and that will be equal to approximately 24 minutes, right? 7 p.m. and 24 minutes. Okay, this will be your final answer. Let's move ahead children. These are your homework questions. Try to solve it by yourself. Be very careful children in questions where you have inequalities, right? Again, this is also your homework. These are of equalities, so it will be easy for you all to solve. These are for inequalities. For such cases children, be very careful, right? This is 0.1, right? 0.1 is less than 1 and they are saying 0.4 raised to power x less than equals to 2. So your answer would be, whatever you get the answer, you will write x greater than that answer. Okay children? Okay, only for such cases where your number, where your base is less than 1, okay, and you are having equality. If it had been 0.4 raised to power x greater than equal to 2, then you should have written x less than the answer obtained. Okay, fine. See now children, for this question, since 5 into 12 equals to 60, should find out that x plus y equals to z. Try to solve this, you will be able to get it. Okay children. The next questions, 5th question, 6th question. This is again GP. What is the common ratio over here? 3 by 1 equals to 9 by 3 equals to 27 by 9 equals to 81 by 27. Your answer is 3. The common ratio is 3. Okay, use that and use the formula Sn. Okay, common ratio 3 is greater than 1. So your formula would be Sn equals to a r raised to power n minus 1 upon r minus 1, right? Okay, fine. Let's move ahead now. See something important. This is question 5. Shows that x is not equal to y. We can conclude that in general 5 raised to power 2x does not mean 2 times 5 raised to power x, right? 5 raised to power 2x is not equal to 2 into 5 raised to power x. Obviously, yes children. What does this mean? This means 5 raised to power 2 into 5 raised to power x. Okay. 5 raised to power 2 means 25. Right? 25 5 raised to power x. Clear? Now 1 billion is 1000 million. This question is also given. A hint is also given to you all. Again, this is GP. What is common ratio over here? Again, it is 5 divided by 1. 25 divided by 5 will be 5. 125 divided by 25 would be again 5. 625 divided by 125 would be again 5. So common ratio would be equal to how much? 5. Your common ratio would be 5. Again, you have a GP over here. Your common ratio is 2. Okay, let's move ahead. How many terms of the GP? This is again a GP. Sum must exceed, your sum must exceed 19.999. So first of all, you need to find your this common ratio. 5 divided by 10, 2.5. 5 divided by 10 is 1 by 2, that is 0.5. Okay. Again 2.5 divided by 5 is 0.5. 1 by 2, that is 0.5. Okay, now here Sn equals to a 1 minus r raised to power n upon 1 minus r. Why? Because r is less than 1. Okay children. So you'll apply this formula and you'll try to solve these questions. How many terms of the GP? Again GP question. Sum to infinity. S infinity children. So it will be a by, what is over given to you all? 4 divided by 2. 2 divided by 4. Your common ratio is 1 by 2. That is 0.5, which is less than 1. So sum to infinity would be a by 1 minus r. Okay. Again a GP question. We'll solve this. Now solve for x. Right, all the bases are same over here. You can solve this question. Solve for x again over for this question, and this word problem also. Half-life, we have done questions of half-life earlier. Okay children. Now this is the 16th question and 17th question. Try to solve it by yourself, and if you face any problem, let me know. Okay children. Bye bye, take care, God bless you all.